In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call.
Yo, Shane, you there? Oh, yo, Shane, you there?
Yep.
Find anything good?
Just this one.
Taylor just sent me two.
Okay.
Send
Are
them
they
to
better?
you. I don't know. I haven't looked. You check these out.
Send me the link. We can test it out.
Oh yeah, I'll test it out with you. Oh, I had you muted. I was streaming it, but I had it muted.
Yeah, I think
Unlucky.
I saw it. And he goes, "Where were you living?" I said,
Nothing
"Yeah, I was living in
going on,
Connecticut." And he
This one's all right.
All right.
There seems to be a lot of flat earthers.
Oh, same one. Same one. Yeah. All right. This is the one.
The other one then, with the Globers. Right? Which one are you watching? Yeah, that one. Yeah, okay.
and Bob was telling me how quickly it became just like common knowledge for people right on television to say, "Oh, everybody watched the space, everybody watched the Challenger explode," when the actual truth was almost.
Lie.
Some flat earthers deny the Challenger. What?
What are they even talking about?
Challenger. Oh, are you in this, Alan?
Oh, Alan's in this one.
Oh,
Yeah, I joined that one. Joined that
you know
one.
the flat earther one?
Yeah. The one that I just posted.
Where?
Uh,
Target.
What the fuck?
what kind of logic is this?
Couldn't they just be moving around us?
We tried to think about that on a simulation and it doesn't work. There's only a globe model that would accommodate all of its movements and to be accurate, which
Which
is why
one's like
I chose.
mutually exclusive?
Excuse me?
What observations mutually exclusive?
Taylor, I think what the
Well,
man is saying is that all of it is mutually exclusive. He's kind of saying that the reason that day and night happened is because of Earth curvature physically obstructing it. That's the reason we can't see stars at different times of day. And he's saying that like the reason that you can see the stars at all and how you see them is, based on globe geometry. Is that kind of what you're putting forward there, my man?
yeah, that's correct. That's correct.
Fantastic. Is that what's your name there? Is it the money? The host? Hello?
It's hush money or shh money.
Oh, shh, money. Okay, I see. I see. The text is a little small. Well, what if I could show you some mutually exclusive evidence that the Earth is truly planar and the measurements of the stars would most likely be due to how we perceive them optically, and the curvature would be an optical effect rather than due to physical ground curvature.
Oh
Would
my
you like
God.
to hear
We
some of
actually
that?
have a real flurf here. Oh, okay. Oh, all right, all right. Let's get this party started.
Yo, what's up, man? How are you?
Yeah, I'm doing all right. Yeah. So, yeah, no, it's pretty much the stars. Really, they knew this like 2,500 years ago. Um,
Mm-hmm.
when we started having empires that traveled over long distances, and astronomers that were able to study over wide enough geography, the observation was made that the stars appear to rotate about two celestial poles. So you have Polaris at the center of the rotation in the northern hemisphere, and in the southern hemisphere, You have a faint star. You can see it with a telescope, but you have a similar center of rotation. And that only works if Earth is a globe. Now, they figured it was a globe and the heavens moved around it. That's the geocentric model. And that persisted up until Galileo. Oh my gosh.
Absolutely, dude.
Level Devil
very,
is...
very accurate so far. So I have a couple points of contention or maybe context to add to that historical narrative. So, we're told that a lot of people realized the Earth was a globe at an XYZ point in their civilization, etc. But the Romans specifically were flat earthers, and they used what's called Roman paces to define units of measurement. So they would define 1,000 paces for how they would do all their maps when they would map coastlinings for everything. Everything would be a ratio of that. And when you get into celestial navigation, all units of measurement are derived, like specifically for the geometry of the Earth, right, and how it's been presented to us, come from first assuming the dimensions first through using angles to the sun. But more importantly, the way that they tell the narrative is like we have this measurement from stadias that comports with the geometry of the globe, and that was a pretty close approximation. And then like the real approximation, like the only difference is like I think it's like 99 something percent between what Eratosthenes measured and what they say the actual dimensions are, right? But the thing about that is all of that, what that all really comports to is positions of the sun, and the distances that they derived under, which I'm going to go over in a second, are actually units of the coordinate system itself, which makes it impossible to falsify because any distance you derive would comport, to that as a trigonometric function following cosines. But where it gets really interesting is when they came up with the ellipsoid model. What they did was when they took the zenith measurements of the stars, because like you were saying, they would take measurements of the stars and then they would triangulate and then traverse the land based on their calculation following cosines. And when they did that, when they look up, a star should be directly in the center of their telescope if it's following cosines, right? Because it'll be 90 degrees relationship, so everything will add up to 180. Now, what they found was that the stars were always off a little bit, and the accuracy of the coordinate system for how they were trying to improve it, was all based off of like a specific snapshot of the sky from the vernal equinox. That's called the first cusp of Aries. So they have this idealized reference point that they're using. So anyway, the difference between the measured value and the expected value, they attributed that to Earth curvature, saying that it must be oblate, it must be tilted a little, or it must be curved a little more here versus a little more flat here, and that's kind of how they mathematically extrapolated it out. They never actually measured the Earth. It's always in reference to the positions of the stars, and then like versus their expected values. But as they would come to find out, the stars have like an annual precession wobble to them, where they move about over the course of the year. They'll be displaced by like an arc second, going in like say towards the east, for example, for a couple of years, and then so over 3 years there'll be 3 arc seconds deviated from where they're expected to be, and then on the 4th year they'll move back 1 or 2 arc seconds, and they have to update the almanacs every year.
That is false.
Wait, Pro, can I ask something?
Oh, yeah, take it away.
Space Audit, you mentioned something about cosines. What were you talking about exactly?
Yeah, so the elevation angles to stars, if you assume an altitude and you have an angle, then you can do trigonometric functions to figure out what the distance would be. So if your units of distance are ratio...
Hold up. Distance to what?
The ground distance computation to put you at the GP position of the star.
How so?
Well, it's a trigonometric function, so if you know the altitude and the angle,
what TikTok
you can know the other side of the
Am I on the
triangle.
wrong one
The
whole
altitude.
time?
Well,
Did you
hold
guys
up.
share it?
Altitude to what?
To the star.
You think you know the altitude to the star?
Well, that's a great question. I personally do not know.
I don't think that's how
None
that
of the
works.
two that are in chat are the two
No,
that you guys
hold on.
are
Let
in.
me finish.
Go ahead.
Checked, like,
But for
7 times.
the
So
computations,
fucking
how it works, right? What you would do is you take
Shouldn't
the
be this
relationship
difficult,
with
guys.
Polaris and how it deviates every 69 miles per degree, right? So using that that relationship.
Dane, I sent you an
if you map
invite
that
to
all the way
it.
down
It's
to
the
the
one I'm in.
equator,
If you
Right.
look in,
That's
I
not
just
using
posted it.
trig.
yeah, or
No,
look
just
in
hear me out
your
though.
Go
Just
ahead.
listen.
inbox to where
You get the distance
it
that would
should
be
show you
that's called a
wherever
terrestrial meridian because you have
Alan
90
is.
lines of
If you go to your
longitude between
inbox
them,
in
or
TikTok.
latitude between them,
He joined.
and you
We got
multiply
it.
that by the 60.
Right,
You could
but
either
just
do
in the
nautical,
future, if
so
you
you
go to
could do
your
60
inbox in
nautical miles per
TikTok.
degree, or you could do 69 statute miles. Doesn't matter.
Right.
And
We're gonna extract
you'll get
Indio from the other one,
6218 or 6214 depending on what you use.
Right.
And that unit of measurement right there, like that straight distance from the North Pole to the equator, is called a terrestrial meridian. And that
Okay.
unit of measurement that we calculated from the latitudes in between and the angle displacement comes out to be 6210. So we use that. We take 1/10,000,000th of that, and that gives us what is called a meter. So now when we calculate the angle to stars based off of 6210 being the base, or I'm sorry, 6218 being the baseline, that's how they do it. That's how they get the baseline, and then all units of measurement are derived
Yeah.
as a fraction of that.
I didn't hear any trig in there though.
Well, you were asking how they got like the unit of measurement, so the
Right.
trig
It
specifically
had nothing to do
you
with
need go over
triangles.
that. Oh, I got you. 1 second.
That had everything to do with
I
trying.
can show you the trig. Give me 1 second. I'll pull it up on the.
This
on
is
the
kind of
monitor
like
screen
Chris
share for you.
insisting that you need right angles to do celestial navigation.
Yeah, this. I think Pro
No, you
went
know,
over this with
well,
you a while ago.
No, I
You
didn't.
don't.
I have.
You don't.
I don't know if I've interacted with Space Audits before, but I
Oh,
have
sorry.
interacted with Chris Van Am, and Chris Van Am has like this weird
Yes.
obsession with right triangles when it
Yes,
comes
I
to
know.
celestial navigation. So it's
I
kind
saw
of like
that.
Space Audits is trying to invoke trigonometry
Where'd he
to
go?
sound clever. Oh, we scared him off, I guess.
Yeah. Well, you throw out words like cosine and etc. Those aren't really big words,
Well,
but
yeah,
you need
you
to be
called
able to back
called
it
his
up.
bluff. You called his bluff. He was saying it had to do with trigonometry. It has nothing to do with trigonometry, and he just ran.
Oh,
Wow.
He didn't run. What?
Just got done doing yard work and all I hear is somebody getting spanked.
Oh, he's back.
Hello, can you hear me?
Hi.
Sorry, my phone disconnected.
Okay.
I'm pulling up the trig stuff to show you guys here in a sec.
Okay.
You guys are fucking too much, you know that?
But I do not agree with the
Every
hypothesis
single
while
one
we're,
of you
while we're
guys
waiting
on
here.
this fucking app. You guys are way too fucking much.
Anyway, I do not agree with the hypothesis that you need.
Anyway.
That you need what?
Like that, you were saying that some flat earther was saying that you explicitly need, right triangles or whatever to do trig on a sphere, and I
Yeah.
don't agree with that. You can take a tangent anywhere. You can just invoke an artificial horizon.
Right.
It doesn't matter. You could definitely do
Yeah,
it. So
Right. And it lines up with the globe model perfectly.
right. Well, I'm about to show you some mutually exclusive
Oh, wait,
stuff.
are you a
people
flat earther or
explicitly
not?
Using trig. I'm a flat earther. I'm
How
about
can
to
you
show
be
you
a
why.
flat earther? Oh, anyway. Okay.
Because I know how
confused.
trigonometry works and how transformations and corrections work. So
Okay. Well, let me see the trig, please.
yep, I'm pulling it up now.
Congratulations, everybody. The first flat earther. Tap that screen if you look flat earth.
All right, we should be good. Let me screen share now. What do I do? Camera. And this camera.
I think I'm done weed whacking for the day and for the rest of the whole month of February.
Hey, what's up? You guys.
Yeah.
Awesome. You got it up, Shane.
What's up?
Shane, go ahead and run through.
Can we go?
Yours
Can you have
then?
a big screen? I can't see. I can't read that.
So we're
Yeah,
talking
pull
flat Earth
Shane up.
angles to stars. This is a nice
What's up, fellas?
Shane's got the
called
same
angles
thing
to
I do.
elevation,
What up,
angles to
lad?
Polaris, right
So
over
we're
here.
talking flat Earth
This
trig
sine
angles
of
to stars.
B
This is a
times
nice
C
spreadsheet.
Where's
times
the
angles
trig?
to elevation angles to Polaris right over
Where's
here.
where's the
This
trig?
sine of B times C22
I recognize
over
this
here,
voice.
right?
You're the guy that talks a lot. Can you slow down, please? I want to go
Yeah.
through this with you.
Sure, man. So what
Okay,
we
where
having?
are the
right?
formulas you're using?
Right here, bud.
Where?
See this? Do you see this formula in my Excel
No, I
sheet?
can't see
You
that.
see how it's highlighted? You see how it says sine of
It
cell
is hard
B?
to see. It is hard
All
to
right.
see.
My bad. Sine of B22, sine C22, right? So we're in cell 22,
Wow.
right?
Wait, what?
So we
Hold
got
on.
sine
He's
What?
in the
of
Why are you
B, so
taking
we're
the
making
sine?
of an elevation angle times
Why?
the hypotenuse, right? Because we're doing basic trig, my man. You see this right here? See this
Yeah, you would
picture?
have to know the height of the star.
Oh, well, we're assuming, right, that everything is an equidistant
Oh, you're talking about.
3959 radius around us.
Okay, that's
Jesus
fine.
Christ,
So
this has nothing
even
to
if it was
do
at
with
60
celestial
degrees,
navigation. This
Yeah,
is
that's using the Earth.
No, it has
well,
everything to
we're
do
just
with
talking about trig because my friend over here was talking about
Yeah,
how I
you
think
have to show
the
exactly.
meter
Don't just show me
was
numbers.
derived. Well, this
Show-
is my spreadsheet, right? It's already filtered to 10-degree separation because
Yeah,
I don't want
know.
to show all
Hold
the
on.
angles,
You're
right?
going to talk right over me. I know. Can you just show me? I don't want to see that. I want to see the formulas
Yep.
that you derived.
Derived. It's basic trig. You're using a triangle. What do
Yeah,
you
I
mean
know.
derived?
Yes.
So all I'm doing
Yeah,
is
it's like one
setting
step.
the hypotenuse, right, to 3959, the visible radius.
Hypotenuse of what? That right triangle that was inside the Earth? The radius of the Earth?
This is it's just a right triangle, right? So we're seeing all the stars
Where is it? No, show me
move in
again.
an equidistant
Show
web
me again.
around us at
Show
the
me the
same
right
distance.
triangle.
What up, Taylor?
Because
Sorry for
for
about to
celestial
drop you
Show me
navigation,
the right triangle.
right? For celestial
followed you,
navigation,
Taylor.
Okay, hang on. Wait, stop.
for
No.
celestial navigation,
No.
homie, it
Go
only
back to the
treat
right
the stars
triangle.
in an equidistant web around
Go
the
back to the right
observer
triangle.
at the same distance, right? If they
You're going
weren't
to
at the
talk right
same-
over me. We're not going to get anywhere.
If they weren't at the same,
Show me the right triangle.
Shane St. Pierre. If you can't like walk through it and answer questions, you're not going to do it.
Yeah. You,
Shame.
if you can't explain it, then you
he's
don't
just talking right
understand.
through it, dude. I mean, what do you want me to do?
Show
You have to
me
bring
the
up
triangle.
trig. Here's the trig. Here's the sine.
Okay,
show me the
Here's the
triangle.
math.
I turned your camera off.
That's-
You can turn your camera back on.
Yeah,
why would
you
you
had
turn
the
it off?
triangle up.
Because
Just
you
show
were
me
being
again,
a
please.
pest and you weren't having a conversation. You were just throwing a bunch of stuff out there, just like Level Devil says you do.
Can I
Yeah,
please
so
see-
we're talking celestial angles from Polaris,
I
right?
didn't see any celestial angles in there.
Well,
on
what
your
we showed
triangle.
you was trig because you balked at trig. You said, "Oh, you
Yeah.
don't have trig. Show me
Well,
trig." And then you
Yeah,
go
yeah.
like, "Oh,
You said
don't
the
show me
trig was for the
Turn your
star,
camera
which
off,
doesn't
right?
make any sense.
So what are we doing?
Show
Well,
me
we're
the
talking
triangle
about
again.
we're talking about
Show me
an
the triangle,
angle to a
please.
star, right?
Yes. Show me the triangle, please.
Show you the triangle.
Yes.
Well, what I have is a spreadsheet. Show me
No,
your
I don't want to
triangle.
see a spreadsheet. I want to see the triangle.
No. I have a
Why can't you
spreadsheet
show where your
expressing the
results are coming
math
from?
to get the angle to the star to
Okay,
compute
I
the
have to admit, I
6218
don't think you
figure
understand what you're saying.
that we were talking about. Well, we
You know
started
what
with
the sine function
6218.
is?
Bro,
Do you know what
we
the
started
sine
with
function is?
6218. No, we
You know what
started
the sine
with the length.
function is?
Holy fucking shit, dude.
Somebody, I'm echoing.
Do
Somebody.
the height of the star divided by tangent of the
No,
degrees.
height of the star.
Height of the star divided by tangent.
No, he's not. That's not the triangle he's using. Show the space audit. Show the triangle.
What is that noise?
One second, I'm pulling it up now. I think I know what you're talking about.
Yes, thank you.
Wanted this one.
Someone just like underwater.
Square root or sexy. You're echoing. Can you mute, please?
Oh, can you see that?
Sexy. Thank you. Mute.
Can you see that?
Somebody else. Maybe it's you, Pro. I don't know.
Oh, shoot.
Okay.
Second.
Okay, so give me a chance to look at this, and I don't know if you're like, but you just wanted to talk over me. Okay, fine. This is a flat Earth model.
Yeah, it's just a triangle. So
So-
we're assuming a radius of vision to comport with the that limit of vision.
Whoa.
Yo, what
Degree
happened?
relationship for us.
Wait. What's the radius of vision?
So you know how on the globe you say that the curvature, is 8 inches per mile squared,
Are you just
69 miles
setting
per
that-
degree.
Hold on. I think I know where
No.
this is going. Are you just setting that equal to the radius of the Earth?
We have a radius of vision. We
And
see
you're setting it equal
curved
to the
visual
radius
space.
of the Earth?
Yeah.
Well, what's the point in that? Of
We
course.
perceive the sky at the same rate.
What do you mean by
Like,
that?
that's what's being used.
This
That's
is the
what's in question.
radius of the firmament?
That's crazy.
No. This is the radius of our vision. So the stars, right? The way that they do celestial navigation, that's what Shane was.
That doesn't.
Please don't interrupt while laughing while I'm talking. Wait till I'm finished and then you can laugh.
Fine.
Thank you. So what Shane was pointing out with celestial navigation is that they treat everything on the celestial sphere at the same altitude. So like when I was saying earlier, when you do...
Who does?
Go ahead.
Who does?
Everyone that uses the latitude and longitude system and follows celestial navigation.
I'm pretty sure that's not how celestial navigation works. There's not a celestial sphere unless you're a flat earther.
No, we just went over how they derive units of measurement based off of elevation angles to Polaris. That was the whole
as lunar disk.
Here, let me show you this real quick.
It is perfectly acceptable to refer to the celestial sphere.
Yeah, but with a known radius, how would you get that radius?
No, it's an infinite
so the celestial
radius.
sphere has an infinite radius. The radius comes from
you assigned it a value.
1 second. The radius comes from assuming a model to put it on Earth. Because remember, I was telling you how they went to go and take zenith measurements of the stars.
Let's not go past that. You can't just assume a radius equal to the radius of the Earth.
Well, the equivalence is optical because it's all derived off optics anyway. So you could say that it's Earth curvature, or you could say that it's optical.
What does that mean?
Okay, so with the same respect of how they say the Eratosthenes, measured the circumference of the Earth based off of shadows and assuming a distance to the sun for his triangulation.
Assuming
so if you make the same,
not a distance.
Yeah, if you make the same, if you make the same assumption and just assume that it's local, you get the same exact calculation. Now, what really sells it?
You don't because you okay.
Go ahead,
Nards, if I may.
Go ahead.
Yeah. So if you have elevation angles to the sun from a number of different latitudes, no three latitudes will when you plot it out over a flat plane, no three elevation angles will agree on where the sun is. Well, no, I guess you could have three. You could have the equator.
No, you're right.
You could have 10 degrees north and 10 degrees south. Those will agree.
You're 100% right.
But the rest of them will not line up the same when you try to plot it on a flat plane.
Right. You're 100% right. The only way that they will ever triangulate to a fixed point is if you move it out to infinity. That's how you fix that problem. But for all intents and purposes, of celestial navigation and how the objects move.
I'm gonna refresh real quick.
Yeah, that's. Hold on 1 second. You can.
The audio wasn't frozen though.
Based off of with the relationship of Polaris when you go to the equator. That's what we talked about earlier. That's how it connects.
Which altitude?
6218. You could consider that the limit of your vision for the position of the stars. You can consider that their altitude.
That'd be the hypotenuse.
That's what gives you the
hypotenuse
ability to
the radius.
Yeah.
Yes.
Listen.
Hypotenuse.
Can I see?
We have the same.
You're talking about the radius, not the altitude. It's a very contrived model. Where did you get this?
Nards, you can just you can pretend that you are in a
you can, but why?
In a planetarium looking at the ceiling.
Yes,
just
but that's not reality. This is a very contrived model I've never seen anywhere.
Is everybody okay here?
Flat Earth.
Or is somebody choking?
Yeah, it's just following cosines to stars the same way.
What do you mean cosines to stars?
So the elevation angle,
and
then assigning the altitude for the celestial sphere.
That'd be the sine. That'd be opposite over hypotenuse. That'd be sine.
He's just saying the law of cosines, bro, not literally cosines.
Does the relationship between the angle and the distance still hold? Is that that's what we're talking about?
Which
right?
angle and which distance? Which angle? Can you point to it? The bottom left? The top?
Yes. The star to the ground and the GP. Yes.
So where's the angle?
Right here?
The angle from the ground.
You're pointing at point. Where's the angle?
From the ground.
That one?
You know how they do parallax?
I don't think you want that angle. I think you want the angle between the observer and the star.
Do you know how they do parallax?
Then it would be the sine. This has nothing to do with parallax. You've drawn a model where you have stars at a fixed distance to the observer. How does that make any sense? And you've assigned the radius of vision.
Well, do they know
Never
the
heard of
distance to the
before.
stars?
Which,
yeah, that's
this
exactly
is
what
very
the celestial
contrived.
sphere is, bro.
Where's
bro,
this from?
No,
This
do
is
they know the
exactly how the
distance to all
celestial sphere
stars?
works.
Where is this from?
That is not how the celestial
You
sphere
won't
works.
answer the question.
This
Okay,
is
thanks for
using
not
angles
answering.
and units of measurement derived from
All
the
right,
celestial
answer her
sphere.
question, you guys.
Well,
No,
yeah.
one
sorry,
at
I
a
couldn't hear.
time.
What are you saying, Taylor?
We've been caught up. Taylor, what have you got?
She asked me about parallax, which I don't believe has anything to do with this.
Oh,
but read
yeah,
up on parallax.
I don't think we're talking about parallax.
But you're talking about angles,
How
and you're just
do we
throwing
know
around
that?
terms.
Do we know the distance to the stars?
Yeah, exactly. My point. That's your model. We don't need it.
Why?
The
Why don't we need
distance
the
comes
What-
from computing it. Nobody knows the distance. It comes from computing it.
Yeah,
through
so
the
why do you have
relationship of triangles and assuming
have
the
a triangle?
altitude because you can get the distance.
Wait,
That's how
Why do
they,
you have a
that's how they do
triangle?
it.
You've assumed the distance to be r, your hypotenuse. Why?
And what do you assume the distance to be?
Not
don't
that.
Is
assume.
because
We
that
What do you
listen
assume it to be?
because Taylor, stop. That is your limit of vision. That is the relationship between the 69 miles per degree
Where
that
do
I
you
was
get the
talking
li-
to you
okay.
earlier
Hey, hang
about
on.
how you can get a distance
How do
out
you
of
get
that.
the limit of vision? Where does that come from? Just picking the radius of the Earth?
Relationship? No, you can derive that from Rayleigh's criteria and the your
Oh, okay.
observer
Can you
height.
show me?
Yes.
Whoever can guess what kind of truck this is, I'm gifting them a galaxy. They just have to come up in the box.
Hey, quick suggestion. Let's not interrupt because I'm not hearing the full thought of several speakers. So please, nobody interrupt any speaker. Thank
Yeah.
you.
It's kind of hard on TikTok when people start filibustering, so interruptions are necessary sometimes. Sorry. That's the way it goes.
Not every single statement that someone makes, though, like without them being
Yeah,
able
but-
to
Okay.
For example, with Shane,
I'm
he'll go
sorry.
on forever and he won't let me talk.
Okay, they should be able to complete a sentence before you chime in.
Yeah, that's fine.
Because nobody can hear anything.
Yeah, I know. I can't see
Yeah, I
that. Can
know.
he
I
have
like
the big
interrupting.
box?
Where's my mods at?
Okay.
The problem with this
All right.
fucking live is
You're
that
using
mods want to be here when it's
that-
time to troll.
Okay, you're
Oh,
using
okay.
that sector, and then what are you doing with it? Walk me through what you're doing here.
Deriving the distance to the
No,
horizon from
don't
just
just say
optics.
that. Don't. Yeah, but show me.
I'm using the diameter of your eye and the wavelength of light, the common like an average wavelength of light.
Okay. Oh, and that's how you get the radius, which happens to be the radius of the Earth.
Yep.
Is this okay? This seems really contrived to me.
It's just triangles and optics, man.
Yeah, you have to be more specific than that when you're claiming the Earth is flat.
Right.
Okay, dude.
I just use
So,
our stuff and be
Now
like,
that we've established how we got the radius of vision,
Yeah, I
now
don't
we're
accept
applying
that.
it to a celestial sphere. Well, it doesn't matter if you accept it or not.
You
The
manipulated
relationship
the
is 69 miles per degree.
You manipulated
is
the
contingent.
input so you would get the radius of the Earth. Doesn't that seem suspect to you?
yeah, then, yeah.
You
No,
get the radius
that's
of the Earth.
average wavelength of light, dude.
The radius. So
how we get into
my
that.
distance that I can see is the radius of the Earth.
Nard, that's
What
how
did
they-
you?
When you
What
look
did
up
you
at the
use for the
sky,
wavelength?
yes, yes,
the
look,
Earth.
What did you use for the wavelength?
Oh, I gotta send this to
666.
fucking-
What nanometers?
I gotta send this to Stingray.
Yes. 666
Yeah,
nanometers.
that's pissing me off.
Okay, show me. Can I see that calculation again? Is this all on a flat Earth site?
What? This is from our Obsidian databases. I have one, and Shane has one.
Okay,
This
so
one
this is from
Shane's.
something that you've made, or something that existed outside of your. You didn't create it.
Well,
This is
I didn't
something-
create this.
Fallacy is attempted
Shane
to
created
claim.
this.
Okay, so he took, but I just wanted to see the Rayleigh's criteria.
Oh yeah, I got you. Let me see. Send me the angulars in the world. Video. Is it in this
Did
one?
Shane create this?
Yeah.
Okay. And just before we get to it, doesn't it seem suspect that our limit of vision is exactly the radius of the Earth?
Yeah.
No?
Doesn't it seem suspect?
No, because it's derived off of optics and how we see in the sky, right? Like with relation to ground positions of the stars.
Don't tell me
Wait a
I
minute.
just want to see the formula.
The whole
Yeah, I got you.
Witsit eyesight, limit of the eyesight was a distance to the horizon, not that we could that we could see stars that were twice Earth's radius away. That's
irrespective of what
that is-
Witsit has said about it, and the distances that you're saying about being twice as Earth radius away, all that matters in terms of celestial navigation and specifically the dimensions of Earth in relation to the latitude and longitude system, you can consider everything in the sky on the celestial sphere at that distance of 6218. Go ahead.
I have to run. I have to teach a class. Can you give me that website? I want to look at that.
Yeah, I'll send you. I'll follow you and send you a DM here.
Okay.
Does that help?
Yeah, that does. Thank you very much.
Yes, sir.
Hey,
You're saying this concludes to a flat Earth.
See you, Pearl.
Yep. Later, bro.
Bye.
Quick question, Space Audits.
What's up?
Is that the same Shane who made like the plagiarized website out of like Wata Bislin?
Yeah.
Like he plagiarized his website and took out all of the stuff that says flat Earth's not real.
You say
What's up,
plagiarized, but
Liliana?
it's
How are
completely
you?
open source.
Well, no, I mean, yeah, but like he took the website and like got rid of all the parts that say none of this is possible.
Well, when you go
Just
over
make
the
the same
parts that
website.
say that was possible, none of that stuff is actually included or relevant in it. So, like, none of it's based off of, like, for example,
it's that guy.
Newtonian dynamics or anything like that.
Okay.
What's
So
that?
it's that guy. Okay. So it's that guy though, right?
Yeah.
Okay.
My
Cool.
boy.
Got it. Okay. Yeah. So
Yeah.
he didn't do any of his own work and just took out the stuff that actually mattered. Cool.
Well, the stuff
Okay,
that actually mattered was in comments.
So did Shane make
Did you know
this,
that?
or did he take somebody else's
Did you know
stuff?
that this? Hold on. You know the stuff that you think mattered was in comments. It wasn't even like part of like the program or like the source code or like that would affect anything of how it's perceived. It was literally things that said like a notation that's like, this is from JPL. This means ball spin and stuff like so. Like when you delete the comments, like the thing that isn't even interpreted in the compiling, like that's a lot of what was removed, and none of that
other than the
matters
Newtonian
at all.
physics and how light works, but yeah, sure.
Well, no, that's what I'm saying, though. None of the Newtonian physics or anything like that is included in it. Like, you can see the source code yourself and go over it. That's why none of it needs to even be in there. It's literally only in there to, like, make him feel better, I guess, the guy that made it. Because it's literally irrelevant.
It's fine. It's good code. Okay, so what's this? Is this
the source code's available, bro?
Or is this somebody else's work, too?
This is a Shane original.
Oh, nice, dude. Okay. Well,
So
he claims the other one's
Shane
dealing
has
with
come
it,
back.
so we'll take that
Shane
one
has
as
come
well.
back.
Fellas.
And I think we can have a more productive conversation here. I think last time we were kind of talking over each other. The mic situation is a little weird on TikTok.
All right. So what's the 666 nanometers thing? What's that about?
Taylor, what happened? You keep going.
Well,
Man, I'm gonna be honest.
Rayleigh's
Like
criterion. What's going on with
pretty
Echo
bad.
here? Oh, we got Echo. Let me stop watching. I think that problem is me. Yeah. So when we talk, you mean like the Rayleigh's criterion, the starting variables that we chose to emulate real life circumstances, right? 666 nanometers is like the red-orange wavelength. It's the most resistant to refraction at ground level, so it gives the globe the benefit of the doubt. And then for the diameter, right, which is the other criteria for Rayleigh's, the denominator, 2.16 millimeters, just because, the range of the pupil typically from 2 to 4 nanometers to 4 to 8, and it narrows the further you look. So you choose 2.6 to be the narrow range. That would be to look furthest, right? So least susceptible to refraction and most squinted, if you would. So that's how we get the Rayleigh's criterion starting angular resolution at 1 arc minute, and then we use that based on the distance to the horizon and the height of a 6-foot observer to get the radius of the Earth, and that's how we have the actual optical equivalence to the derivation via the Pythagorean theorem of a sphere of radius 3959, which ends up being 1.225 times the square root of the observer's height in feet. So for a 6-foot observer, you still have a distance to the horizon of 3 miles. So for the human...
Okay, so what about a human with larger pupils? Because I feel like that would skew the results by a lot.
What'd you say?
A person with larger pupils, like where you don't assume somebody's pupil dilation. Like, what if it's got a larger? What if it's like lower light? You know?
Yeah, I mean, so this is a very specific circumstance. Also, these circumstances change by the second, so it's really an estimation of a snapshot in time, right? To be this exact wavelength and to be this exact diameter, in all honesty, right? So it's an estimation.
So this suggests that the radius of Earth is simply just the way our eyes perceive a flat surface?
Well, no, specifically it's tied to the angular resolution limit, which is how we got into the wavelength and diameter. And then when you get to other optics, you have the same angular resolution limit. You can say, like, you know, large telescopes of 1,500 nanometers and a diameter of 5,000 would also yield the same angle, the same theta, which would get you back to 0.1 degrees.
I got a question. When the sun sets right here or rises, and we can see that line, that definitive line, is that our limit?
I would say the sun is a pretty good delimiter of your actual celestial limit, bro. Right? That's the furthest thing you can see.
So based on your specific numbers and based on a totally not
So the sound effects.
totally not on purpose shows that you get 666 nanometers because you don't think the Earth is evil or the globe is evil. Totally random. That just happens to be the least scattered light, which I don't believe is true.
But if I hear one more thing that's funny, I'm gonna have to hit all of them all at once.
Oh my god, dude, this is the host.
Man, I wanted to do your mom joke, but I couldn't.
Right, we can use like near infrared, thermal imaging, far ultraviolet. You can know all sorts of types, and you can get infinite tuples that will satisfy the result to get the required angular resolution limit. So it doesn't.
So what
it's not
about
really tied to your eye? It's
purple light
it's a formula.
and my pupils the same size? That wouldn't yield the same result.
Well, the same way you can plug in other non-realistic diameter that will get you a different radius, right? That will certainly not yield realistic results. And the same way you can falsify that going the other way. And when you see something like the black swan well beyond the horizon distance, you have to falsify it to change the distance, to add refraction in, to make the Earth radius bigger. Otherwise, it wouldn't work, right? So it works the same way.
That was a whole lot of words, and I don't know, man.
Well, so you can pick different tuples to satisfy it and prove my point, and you said you could pick other ones that make it a larger radius. And my point was, yeah, that was the point of making the spreadsheet, to show that you can choose different values to get this. So you have to falsify the distance to the horizon. Would mean it would have to be a larger horizon, which falsifies the geometric principles of the globe. Right? That's what started the equivalence that we started talking about with the optical distance to the horizon on a flat plane versus the geometrically calculated using Pythagorean theorem of radius 3959.
I don't know. It still just seems like you cherry picked two values to make it match your assessment of we claim the globe to be.
Right.
With the very cherry picked 666 nanometers, suggesting that the globe theory is evil or something. Like you could have chosen 665 and fully avoid that's basically the same color.
Well, no, you can ignore all those and choose totally different parameters. Like I said, for large telescopes, near infrared, thermal imaging, something like 1861 nanometers and 600 diameter will yield the same angular resolution limit, the same theta, the same angle. So for something like thermal imaging, you can really yank it up, go 2792 nanometers to 900. So there's different tuples that satisfy it. So the argument that we cherry pick 666 doesn't really hold true, right?
Right, but here's the thing. But why is that also justification for the fact that the globe is false because you can do that? I'm not seeing the connection here.
This specifically doesn't falsify the globe. What I said it falsified the globe would be an observation like the black swan, which is something like 6.2 miles beyond the actual calculated observer, where the horizon would be for that 6-foot observer. So the only thing that we're showing is an equivalence. We're showing you get an optical drop-off.
So it basically a mirage image falsifies the globe?
No, we're talking about it would look the same whether you're on a sphere of radius 3959 or a flat plane. That's our argument and our position.
Oh, right. Okay. So basically, so that one fact is a falsification of the globe in your opinion, right?
This doesn't falsify. This is just showing an equivalence, right?
Oh no, I was just no. I thought that was the conclusion you were making. Like not that debunks the globe, as a lot of people like to say, but that bit of evidence, in your opinion, would be the same on a globe or flat. So we can't differentiate using that evidence. Is that what you're saying?
Exactly.
Okay. Then what about the thousands of other evidences? Are you actually a flat earther?
Would you like to see a new one?
What's your best
Would
evidence?
you like to see a new one?
The fact that the sun sets every day, that's evidence. That's the best evidence.
Okay. That cannot be your best evidence.
So before we get to
the sun sets and the sun doesn't get smaller.
That's your best evidence, seriously?
That's the
that's
only
a pretty good
evidence
one, Taylor. It's a pretty good one.
It's
not.
There's so many others, but that's the easiest to observe, and everyone can observe it every day. The fact that this.
Okay.
Oh, have
You're
some
good.
rights here.
So
the fact that the sun
let's
sets.
do a null hypothesis on it and see if we can determine if a sunset alone can tell us if that is evidence for if that is evidence for a globe or not. So let me show you something here. So the globe makes different geometric predictions for shadows at sunset. Now, primarily, this is a multifold argument here. Can you see this? So what we're looking at here is Mount Rainier casting a shadow into the sky, and people will say, this is mutually exclusive to a globe. It can't happen on a flat Earth, but we're going to look at some examples of how it can, and we even have it modeled, or this was even modeled out by an engineer, and we're working on making the source code available. Welcome, Hasselblad. We get to continue our shadow set conversation. Are you ready? Or well, let me finish this, and then we'll pick it up where we got to last time. So this is what the globe is showing here. Now remember, this is a multiple part argument. So if the Earth's curvature is causing this, when the sun is setting, there also, in addition to this shadow here, there needs to be a hard cutoff shadow that's arcing across the sky that's going east to west as well. And the same thing also has to happen for sunsets. It's going to have to be twofold there. So there's a missing additional shadow here, which is said to be the belt of Venus, but we'll go over that here in a minute. But right now we're only looking at the best possible evidence. Okay, it's facing upwards. This must mean it's a globe, right? So when we go to the top of these mountains, and it doesn't matter what time of day you do this, sunset, sunrise, what you'll see is these shadows will converge to the horizon. They'll go all across the horizon and converge. This is an optical effect. When you're at the top, it just goes to the horizon. So when you're at the bottom looking up, you see it gives the appearance that it's going up at an angle. It's just perspective. It's not actually
what time of day is
doing
it?
it.
What time
Hold
of
on
day?
one second. Doesn't matter. Any time of day is good. Anytime.
It
Morning,
so
night, doesn't
no
matter.
no pushback on what you're saying. Then you don't want to provide.
We will go over let me continue this, and we'll go over a simulation of it.
Well, the way a discussion
To scale.
works is you.
No, yeah, I got you.
Hey,
I got you, but you're not going to interrupt on a
are
dead
these
point.
both at the same time of day?
Hey,
That's the question.
Nope, and it doesn't matter.
Hey,
Liana.
That's a weird.
Sorry.
Liana.
Sorry, Damon. Damon, are you the host? Is that your name? Damon?
Shmoney?
Can you hear
ma'am.
me?
Yes.
Okay, hey, real quick, I just wanted to request two little things. One is that nobody should interrupt anybody else. I don't care if they're flat or globe or whoever. I want to hear the full thought. That would be really productive. And the other thing is, if people start saying word salad or something, then I think we have to come to an agreement that those people have very poor vocabulary skills. So, because I don't.
Well, Liana, if someone's going to talk for 20 minutes and somebody's just asking for a clarifying question, would you not agree that is understandable and even smart?
I think that if you're really interested in knowing, you will allow the person to explain everything fully.
Right, but if
The
a teacher is
interruptions-
teaching a class and you're trying to get a clarification on what they're teaching at the moment, you would say, hey, can you clarify that for me? Are these two things the same?
Why don't you just note it down and request later? Because
I'll do what I like, but thanks, Liana, for your position. If Hush Money didn't want me here, he wouldn't have invited me to the live.
I know the interruptions are so annoying, though, Hasselblad.
Yeah.
Maybe
and
a 1 minute.
To be
wait,
clear,
1 minute
Liana,
good.
you
It's all good. We
interrupted
can-
everything that was going on to say interruptions are annoying, so that's kind of weird. But
It's
go
all
ahead.
good. We could address it right now. So here is the simulation of it, modeled out to scale with Mount Rainier. The distance and location of where this original picture was taken. This one right here. This dude modeled it out to scale. Now, also keep in mind there was a secondary shadow that's going to be produced by Earth curvature that's going to go across the land here. This is why I said it doesn't matter what time of day.
What
This
do you mean a
effect is going
secondary
to
shadow?
happen all throughout.
What do you
it.
mean a
Just listen.
secondary shadow?
From actual Earth curvature. So this
You
shadow
mean
produced
a
here.
shadow of the Earth, not just the mountain.
Yes.
Okay. What's going across the sky there? What's that
Oh,
dark
1 second.
portion of the sky beyond that triangle?
1
At
second.
the top of your screen, you see
This is
clouds,
with
and then you see
this is
darkness
with the
at the top.
appropriate. Jesus, man. This is with the simulated ball curve.
Yeah,
That's
what's
not
the
present.
shadow at the
Yeah,
top?
no, he's looking at the curve and he's saying that that's real, but it's a simulation. He doesn't know that that's not real, right? So we can continue.
This is him simulating out what it's supposed to look
Okay,
like.
you said there's a secondary shadow. We agree there's a triangular shadow, right? But then the rest of the top of the screen is dark, right?
Hey, Hazelblad, that is a simulation, my guy.
My
if you
guy.
paid attention, you wouldn't try to be using a simulation.
Yeah, see, this is going to get derailed really quick. So
No,
what
listen.
is that
Let's
second
hold
shadow at
on.
the top?
Before we get super derailed, this second shadow is a simulation of what the hard cutoff shadow would look like. That would follow.
Can you show us?
that-
Can you show us the
I'm showing it right
position
now.
of the light to create these shadows? That's the ultimate question we have. That's where we ended last time. Where does the light have to be to get the shadow to go up?
He's trying to throw you off, Alan. Just keep on
No,
going.
totally not trying to
Above.
throw him off, Sacred. That's where we ended last time. Where is the
Pay
position
attention. He's going
of
over
the
it, bro, in
light?
detail.
Always above. Always above.
Always above.
I can show you a demonstration of it happening where the light source is always above.
Just show that. Just show that.
Okay.
Listen to him, Alan. Finish what you was doing. He don't dictate nothing.
How can you possibly listen while you talk all the
Sacred.
time, dude?
You came to our live. Guess who has control?
For you, gang.
Not you.
This isn't your live.
Yeah,
But
it's
you're right.
it's
We
Hush
are over
Money's
here
live.
looking for smoke because you
Hush
don't go
Hush
nowhere
Money's
else.
live.
Yeah,
Listen,
we
the
here.
thing is,
Pay
listen,
attention.
I don't mind.
Can you
I don't
show
mind
us a
doing quick
demonstration
divergence real
of the
quick?
light? Can you show us
Yes.
a demonstration of the light being above the object and casting the shadow up? In the same
Pay attention.
way
Here it is.
that we
Don't
see.
interrupt.
Yeah. Why don't you shut
We're
the
gonna watch
fuck
this
up?
2-minute video. Here we go.
Person already triggered.
Yeah.
Level.
No,
It's not changing height of the sun, just goes
ahead,
Here we
away.
go. Here we go.
Okay.
Pay attention.
You will see from the other angle that it
I'm gonna
goes
play it
down
at 2
due
times
to
speed so
perspective.
we can get.
As it goes down, as the sun sets, the sunlight hits the mountain and causes the shadow up on top or on the bottom of the
Light
clouds.
source above.
At that point,
What shadow are
shows
we
the shadow.
looking
Hold on,
at?
1 second. We're gonna get
Check it out
to
from the other
We're
angle.
gonna see a second
Watch the
perspective.
shadow as it's
I'm curious of the shadow
away,
here.
and going away. See the shadow. You see the sun now. As it goes away, it appears to go down.
Okay, can we
Perspective
see
again.
the shadow
Let it go,
that's
it's gone
not on
all the way down to the horizon? But see, there's the shadow.
Notice the light
Upward on the bottom of
source
the clouds.
appear to be falling
never
while at the
changed height.
same elevation.
Mm-hmm.
Surface, by the way.
Mm-hmm.
So this is what I was trying to get you to do the other night when you had.
So that box is
right
touching
there.
the top of the triangle, right?
Correct. And
Box
thus
is
causing
touching the top of the triangle.
yes. Thus
So
causing
I think that shadows are only created when
not the
things
same
touch
thing we're
touch the
seeing in
surface.
reality, because those clouds in the other photo weren't touching the top of the mountain, right?
When you go to the
Shadow would
top,
disappear if
So
it
can you recreate this? Could you recreate this right now with the box being like a foot above the triangle instead of literally resting on top of the triangle?
You know you could create a shadow without touching the surface, right?
Sacred, are you dumb? Of course I know that. Can
Okay,
you
so
recreate
so
this
that's a non
effect?
sequitur
Can
then.
you
So it doesn't
Yeah,
matter.
yeah. Sacred, we know you love the sound of your own voice, but that's okay. So can we
Hey,
recreate this without
whatever you want to
that piece of
project, my boy.
cardboard?
Whatever you want to project.
Can we recreate
Definitely
here?
projection.
Here, how about this? Now we can actually have a conversation. So can we recreate this with that cardboard not touching the top of the triangle as it was
Yes.
in reality?
You have such high
Yes.
testosterone, huh, Hasselblad?
Say what, Taylor?
I said your testosterone must be so high.
Yeah, it is. Here, let me show you how high it is. There we go. So can we recreate this without the
What a
cardboard
gay boy, dude.
touching the triangle and make it a
Yes.
1-to-1 to scale? Because so far
Yes,
you're
we
not
can.
showing it to scale, right? You're just saying, hey, look, I put a surface close to this thing, and then the shadow appears to be casted up.
Well,
But it's
listen,
literally touching the object that's creating the shadow, right?
here's the additional problem for you that we're kind of skating past, right? Remember this oversweeping shadow that isn't present, but we're looking at in the simulation here.
So
This is the
this is why
secondary.
I was
Hold on one
asking you
second.
earlier.
This is the
This is why I was
secondary
asking you
component
earlier to
to
define what you
substantiating the
mean by
difference between these two.
oversweeping shadow.
Dude,
What
the black
There's
oversweeping
a
shadow are
hard
you talking
cutoff
about?
that's going. There's a hard shadow that's going to sweep across the land at 15 degrees per hour, corresponding to the rate of
Do you mean
rotation away
nighttime?
from the sun.
Do you mean nighttime?
Yes, and that would happen.
Define
So
what
what
you
we're
mean by
okay.
hard shadow sweeping across the land. To me,
It
that
just
means
means a dark.
nighttime.
It just means
If the
darkness.
sun
Yeah.
goes below the curve of the Earth, it would make a shadow in that shape across the sky. If your
Yes, it's called
argument is
nighttime.
correct.
It's
Okay,
literally
let's move
called
No,
on.
nighttime.
no. Listen, it's actually what you guys try to say is that it's
With dark
called the belt of
clouds.
Venus, and
Okay.
what we could look at right here is that that's not the case. Here we have the sun above the horizon. We're looking at high weather balloon footage here on a GoPro. We see the sun is still in above the horizon. The light has
Uh-huh.
attenuated. It's reached the terminator, and this is what we're looking at
Now
here.
wait. Now wait. Do you think that sunset is the same time at sea level as it is at like 30,000 feet?
So, listen, all of the
Do you
this is
think
what I'm trying to tell you.
sunset is the same time at sea level as it is at 30,000
Listen,
feet?
guy, the luminosity produced
Do
by the
you think
gases from the
sunset is
do
the
not.
same time at sea level as it is at 30,000 feet?
I'm not going to. No, listen.
Okay, so no. So then
What is based on the ground
why
is
are you
elevation
showing
angles to
me
the sun to determine twilight, right? Not the luminosity. What we're talking about here specifically is they're saying that the belt of Venus is created
Okay.
by the
But
Earth's curvature
you
being
ran
that hard.
away from my
Stop! Do
original
not, man.
question.
Listen.
You ran away from my original question. We were talking about the shadow. You showed your demonstration of the shadow. I asked you if you could repeat that
This dude
without the cardboard touching the triangle.
His avatar
Now
is
you're
probably the
taking us
most
to a completely...
accurate
See,
picture
this
he's
is
ever
why it gets
used
annoying
to make
talking to the
himself.
two of you. You never stay on topic. You jump to a different topic when we're trying to drill down on something. And then you like to use big
Freaking, who is
words
playing
thinking that
music,
people
dude?
aren't going to catch on to what you're doing.
No, you
Can
interrupted
you
incessantly and threw
recreate...
out
Hold on,
7
was
non.
nearly done. Was nearly done.
Can you mute the
So
host? We
can
asked
you
Wasted Rock to hear that.
recreate the shadow being casted up from your little triangle with your light on the card jack that you had? Can you recreate that without the cardboard touching the triangle? Can it be several feet? Do that.
Well,
If you don't have it,
Hasselblad,
do it
you
and come
ask
back.
Hasselblad, you ask questions, but then you interrupt 3 words later. So I don't
Yeah,
think that
because
that's
they're
a
talking
fair
about something
interruption.
completely different that has nothing to do with the question, Liana. Do you get that? If I say, hey, what color is my car? And you say, well, I'm going to go ride my bike today. I'm going to interrupt and say, no, the question was about the color of my car. So we're talking about the demonstration. Now, I know that Space Audits has been chomping at the bit to have this conversation with me since the last time I asked him this question, and it was crickets. So now he found a video that he... But the cardboard is literally touching the
Yeah,
top of
it's
the
touching
little
the
triangle.
mountain.
Did you quit, Alan?
So
Yeah.
basically, so Hasselblad, you only want one-word answers, it sounds
No,
like.
I don't want one word answers. But yeah, if I ask a yes or no question, I don't need a word salad on that
Right?
has nothing to do with the question.
Whenever you say
Right?
word salad,
Yeah.
it just shows.
Okay. So can anyone demonstrate,
Kick everyone
Shane,
every
how
time they
about
try to
you,
say
since
anything to
Space
him.
Audits has left,
Dude,
since
what
he
did
didn't
he
want to
do
stay
with
on
your
topic and
little
got
thing?
upset that he was muted,
Yeah, they're the worst.
can you demonstrate what
Honestly,
we
the worst.
see in the picture without the cardboard touching the top of that pyramid?
Especially as soon as the guy Hasselblad came, it was over. But before that,
That's
I
what
think
I
we nailed
thought.
him pretty well. Even though that first
Damn.
guy was just an ignorant prat too. Dude, there's so many just terrible people. So disheartening.
But ask Hasselblad if he wants to have a fair debate on a neutral platform.
I like how
So
they tried.
I find it a bit odd that you guys
They
want to
tried.
come in here and you guys come in
Yeah.
here, you try to have the conversation, you try to use your big fancy
Oh,
words,
that's good.
you guys try to be
All right. I
smooth
don't want to hear his voice
talkers.
anymore.
Oh,
Yep.
we're so scientific, we're so this, we're so that.
Yeah.
But the last time I
What?
talked to Space Audits, he got immediately
Up
quiet
to
when I
another one?
showed him what I was talking
This
about
guy seems to be
with a
doing pretty
simple
well.
toy and a kitchen light. Hey, the kitchen
How did
light's
you?
above the toy.
Oh
How
my
do you get
gosh.
the shadow
His
to go
voice,
up?
bro. It's like,
Now he claims to
answer my
have
question.
it,
Okay,
but
here's the
he's
answer. Oh,
not
nope, you didn't
doing
answer
it
it fast enough
the
with the words I
same
was
way it's
asking.
done in reality. Those
Exactly.
clouds weren't
It's like
touching the top of the
man-child
mountain.
syndrome top behavior over there.
I'm done.
So childish.
Mhm.
And then you run when I push down on it. You guys complain that I'm
Ask
not letting
Sorry,
you
then you have
answer,
to
but you're
silence.
answering an entirely
It's
different
crazy how
question.
Alan's like, yeah, but what about the part?
Like,
That's
what the fuck?
wild.
We
There should
can
be a
have a cordial
second shadow that should
conversation.
come
Just
across
stay
the
on
whole
freaking
sky. And
topic. If somebody,
what are you talking about?
if you're
Yeah.
going to
I just
explain
showed you, and
something
then
and
it's like,
say,
you didn't
Dude,
answer
you know
my
what was
oh, there
funny?
should be this
He was
shadow.
trying to show
Well,
it. He
what
was like, "No,
shadow
that's
are
it. I
you
see it. You
talking
mean like
about?
there, like
Oh,
there?
I'm
You mean
sorry.
I
I
should see
asked a
that?" And he
question
didn't
while you're
understand that
explaining
this is what
something
you
to get
never see, but it's
clarification.
what's simulated to be
Get
seen.
the
And he was
fuck out
already
of here
jumping at
with
it.
your
And then he
bullshit.
got out of it by bringing up 7 non sequiturs and just scattergunning. It's ridiculous.
And then kicking
What's
people
up
who
with
were trying to tell
Taylor?
him he needs to answer the question.
And
All right.
and here's what pisses me off about Sacred, Shane, and Space Audits. They like to use
TikTok
the
is the
big
preferential
words. They
platform
like
for
to
faggotry,
act
as
like
it
they're
appears.
being scientific. They
I
like
know.
to use things that the common man isn't going
Also,
to
you can't
know.
say retard or else
So
you
if
get
they're
banned.
walking down the street and they walk up to somebody
You
and
just
say,
go
"Hey,
Papa retard.
did you know the Earth is flat and here's why?" and then they go on their
I
spiel
need to say it.
using
I
their
need to say
know.
it
words.
like 3 times a day, or else
Yeah.
I just, I get really
So they
pent
go
up
on their
and angry.
spiel using their words. It's
Yeah, I'd agree with that.
extremely dangerous
How is that
because
an
they're going to be
danger?
able to bait people into
Like
this
30.
because
Yeah.
they're
30?
using
Get that out of your
words
system.
that
Get
they
7.
think
You
makes
need to
them
get
look
that out of your
smart.
Right.
system.
And they're right.
Right.
To the
That's his way out.
unknowing
Yeah.
person, it does make them look smart. Yeah,
Matter of
take a
fact,
seat,
anyone
Yeah.
that
Sacred.
doesn't say
Take a fucking
retard
seat.
at
You're
least
not
twice a
coming up
day,
until
I
I'm gone, Sacred.
absolutely agree with you, Hasselblad. That's why you were number one moderator.
Matter of fact,
That's
if you
why
don't say retard, I don't think we can be friends.
I don't question, and that's why I believe strongly.
So, but all they say is gobbledygook. It's fucking
Yeah, I
the
know.
Space Audit's
Oh, I
main
wish I could
argument
get in there.
is we have
Is there a new
globe
one?
vision. There is a limit to our vision, and that limit to
Think
our
so.
vision happens to be the same
Hearing
amount
Jesus
as
is
Shane,
There's no
please,
way that. Yep.
please find me a
time
solution
of
to where I
judgment.
can do TikTok on my PC. I know you can do it, Shane. I know you can figure it out.
You can do it with an emulator.
No, you can't.
Can't do it with like an Android emulator?
No, BlueStacks is not working.
There's a bunch of emulators though, right?
They all, that's like the same principle. They can tell. TikTok don't play. That's the other one. Said he paused it though. Okay.
No, you have to refresh. He didn't pause it.
Oops.
If
Like the
I
next day.
have an Apple
You know what I mean?
device, do you think TikTok will
Guys,
lessen
I've never
my
seen a
information?
road get built before, so I don't think
Than if I
roads are
put it on
real.
my
I think
Android
they
device?
just were there naturally from aliens.
You've never seen a road be built?
Sure.
Yeah, I've never seen like
Yeah,
a
no,
highway.
I think you're onto
with
something
them,
there.
So
I think you're onto something.
No. I get his logic, but you've never seen a road be built.
No,
You've
I've seen
never
them
seen
repaired.
some dudes laying down asphalt.
No, I've seen them like get repaired and shit, obviously, but they look ancient as
Yeah, but
fuck. So
I do
it's
the
got to
same
be
thing for
aliens that made them
Instagram,
because
and
I've
it
never seen them like
still,
just make a natural
listens
freeway
to
or
my
anything like that.
audio and gives me ads based on
This reminds me of a post that I saw a while back where it was like, you know how people say that like that pyramids were built by aliens and stuff? What if we did that for more modern buildings and went up to, so like somebody goes up to a building and go, humans could never build an apartment this complex.
And then EYES, like eyes, essential eyes.
It's just statics
That was a nice app.
and mecha
It's
materials.
that I mean, they call it an apartment complex, not an apartment simple.
Not an apartment simplified.
Yeah,
I'm gonna
It
start doing that.
has to be aliens. Aliens can't do the
I don't
complex.
think Apple allows stuff like
It's
that.
actually been my
Quantum
argument
dot.
for a long time.
More, but like,
All right, but they made flats
Okay,
also.
Gavin,
then
Gavin.
again, Apple also does the
Yeah.
whole like ads for what you
Yo,
think
did you
about
say you? What's your field of expertise again? You were saying?
Me?
Yeah.
I'm a nuclear and particle physicist. I'm in grad school. I'm a PhD candidate.
Oh.
Nice. What are you PhDing in? What's your candidature in?
Nuclear and particle physics.
Just said it.
Oh, right. Gotcha. Okay. Sorry. I thought you were misunderstood there.
Yeah.
Very cool. I heard you talking
but I
about
do
Kershaw.
research on.
What is this?
Unstable
That's what I
connection.
was saying the other night, man. I told you about this. You said it wasn't happening to you. You
It
said you were
wasn't.
different.
I also do R&D.
What the fruit fly? Oh.
Stick. Hang on one second.
Yeah. All of that's
What was the name of the first
essentially
one?
relativistic heavy ion collider, or RHIC, R-H-I-C,
It means they're taking ions and moving them really fast.
and smashing them into each other.
Yeah.
Specifically, I'm in the STAR collaboration.
Nice.
And actually, next October, I'm going to be spending 4 weeks there to operate the detectors.
Well, that's exciting. Is that similar to the kind of thing that they say they do with muons? But you're just doing it with a
Muons?
different type of particle? Like you're accelerating it and colliding it kind of thing?
There's only one or two other experiments that actually work with muons, and those aren't really popular, big. So I'm curious what you're referring to in those experiments, like muon G-2, maybe.
Yeah. So specifically, I was referring to just like you said you were accelerating a particle really fast, so I assume you were using like a magnetic field particle accelerator kind of thing.
Yeah. It's like similar to what they do at CERN.
Right. Okay. Yeah. So exactly. So like with the muon or whatever.
Well, they don't use muons. They also use ions.
Didn't they do the G2 muon thing there? Or am I mistaken?
G-2 was done at Fermilab in Illinois, and I actually worked on that as an undergrad.
Oh, gotcha. Oh, check you out working on the Fermilab.
Yeah.
I know a lad who's on Twitter who had a part in that, I believe.
Cool. I wonder if I know them or if I've met them back when I was an undergrad.
Yeah. What's up, Proud?
But yeah, no, we just use heavy ions, and obviously for the EIC, the electron ion collider, that collides, ion.
Don't you say anything, Gally, I swear to God. Why? Because the shields are up? What is going on?
What if you get rid of the referral in the URL?
Same principle as a light beam, but instead they're just using an electron beam.
Yeah.
Okay. I haven't
So-
really. I don't know of a specific experiment doing that.
I'll have to look it up. It's a Russian name that's too hyphenated or whatever. But anyway, what this guy did was use an electron beam, and he had a solenoid magnet. And basically, the way that a solenoid works, they predict that the strength of the magnetic field, would be inside of the solenoid, and there wouldn't really be any on the outside. And what they measured was like a deviation, basically like the waves were bending around this field that isn't supposed to be there or whatever, and they measured an interference pattern based off of like the strength of the magnetic field of like where it wasn't supposed to be. So I'll get the link for that here in a second. But the reason I brought it up was the you're saying that like your interpretation is that these are subatomic particles, and
they are.
I wanted to ask like what are your thoughts are on the relationship between like light, for example. They say like double slit experiment, but all of like technology is based on like the wave function of it, like specifically interferometers and
this
stuff.
This is just a terminology thing. We do in the field we still call them particles. They're not classical particles, so they don't have like a definite position or momentum. In the regimes that we're working with, though, we can treat them like that. But at lower energies, when quantum mechanics really comes into play, yeah, you treat them like wave packets and things like that. I often like to use the term wavicles, because they're not really waves, they're not really particles, they're kind of something in between, with properties of both. So it's a third thing. It's a wavicle.
So how committed to you or to the idea that there is no ether versus like that could be like an underlying
we fully
structure.
debunk the ether every day.
Whoa! What the? Okay. All right. I need to get.
Love saying that.
I need to get some backstory here.
What's up?
So what's everyone's position here? Because apparently some of you guys are flat earthers. I don't know what's going on. I'm half.
Oh, I got you.
We're all ether cosmologists, homie.
Yeah, I'm a flat earther, but I'm also an ether cosmologist. And what we were discussing,
what is an ether
before.
cosmologist?
So
you huff ether and then
deduce it from the name.
Like I don't.
Mainstream physics is propped up by three main pillars, right? It would be special relativity, general relativity, and quantum electrodynamics. And QED is largely supported by the special theory.
That, but okay.
No, there's more than that. You're missing a few.
Yeah, there's a lot more than.
What about quantum chromodynamics?
Right, well,
That's literally my entire field.
Physics, yeah, well, I'm saying in terms of physics, like overall, right? Everything breaks down into special, general, or QED, right? Like more or less.
No.
That's kind of what we're
not
looking
really. No.
Nope.
More precisely.
My field, quantum chromodynamics, is not described by any of those.
And then you can also just have like classical mechanics. Like if I'm dropping a ball, I don't really need general relativity for that.
True, but
but they say that classical
like,
mechanics is like
level.
a weak approximation of special relativity. So like if you're in low velocities or a low gravitational field, then like the classical would just be so like they're saying
that part's fine, but again, you're missing the strong nuclear force and the weak nuclear force for that matter.
So quantum field theory though is that would be like the overarching thing, and then you would have subderivatives of that.
There's no one quantum field theory. There are quantum field theories, plural.
I got you, but just listen to how I'm trying to like relate this, because I think we're saying the same thing, but because you're in quantum chromodynamics, that it's a slightly different thing. So I would like to give you recognition for your field, but I'm saying that there's like three primary
I'm saying that
things
has nothing
that
to do
are
with electrodynamics.
Wait, okay, hang on.
Those are different fields.
So you believe that like subatomic particles exist, right, Space?
No, I have a different interpretation of what they are.
Oh.
I would say that they're toroidal vortices.
So what runs your phone?
The same information.
He's just saying that there's something else.
I
got this.
Yeah, you're good.
I know, but
so his interpretation is that it's particles, but it's all backed off of wave mechanics.
It's not an interpretation. It's backed by data.
Well, that's what I would like to get into the specifics with you about, because I was asking you, if you believe in the ether, like how opposed to it are you. And you said we debunk the ether every day, so I kind of wanted to get your experience and like what you mean by that, so we could move forward. What's up?
Well, the biggest thing is that ether does not predict time dilation to occur, and in particle accelerators, we see time dilation occur all the time.
Yeah. Okay. So you're familiar, you said you use special relativity a lot. You know what Lorentz symmetry is, right? Space-time symmetry.
Yeah, Lorentz.
So, and you know what facilitates a successful Lorentz transformation? That would be the change in time and distance, right?
What do you mean a successful? It's just a mathematical shift between reference frames.
Oh, I'm sorry. So to satisfy covariance and to show reciprocity between the frames, the distance and time are going to be different in the moving frame versus the stationary frame, right? And then if you were to do a transformation,
time dilation.
Right. Well, hold on. But it's symmetrical, right? Because if the time changes, the distance will also have to change. So
Yeah,
what
that
they
you get
do,
spatial contraction as well. Yes.
yep. So can you
We
show
observe
me
that too.
can you show me the experiments where the lab frame is contracting in the muon frame? Or is it just a one-way measurement of time dilation where you're not showing reciprocity in the frames? Because you'd have to substantiate that.
That's not exactly how that works, because you can just show that through a mathematical transformation it has to. Like, the distance and time that the muon or whatever particle you're talking about is traveling is matching exactly what relativity predicts, and if it matches what relativity predicts, then the reverse has to be true as well.
Well, I certainly agree that that is one of the postulates, and you can assume that, and it certainly calculates that way. But I'm saying, like, the difference
And
between kinematics.
Regardless, I have not seen any theory that predicts time dilation for unstable particles to match exactly the form that it follows we see in reality, besides special relativity.
Yeah,
Like,
well, give me 1 second.
Special relativity and general relativity, nothing but net, dude. Like every single, like, shoosh.
Yeah, literally every single test that we have been able to
run.
We
can get to the Sagnac effect here in a second.
Even when Einstein thought he fucked up one time.
Sagnac effect still agrees with special relativity.
No, it doesn't.
Well, hold on.
Dude was so smart. He thought he fucked up, and it turns out he didn't fuck up. His fuck up was that he thought he fucked up.
Pretty much, yeah. And again, like, time dilation happens. If the ether was true, that would not happen at all.
So listen, though. The reason I was bringing up the reciprocity, right? You can calculate that for what the lab frame would have to contract if you were in the muon frame. But that's actually never been substantiated. And the only thing that you extrapolate meaningfully out of the calculation is the change in time in the muon frame. You don't actually measure, like, a distance of or like a contraction of the muon.
We do actually. We do measure the time the space contraction of heavy particles.
You'll have to show me what that looks like. I'm not familiar with the heavy particle.
So heavy ion collisions.
Knowledge. Yeah, go ahead.
Forget the muons. Heavy ions is where it's at. So heavy ions actually have, like, a bulk size, right? And muons are treated as point particles, so spatial contraction, you don't observe that happening to them. But if something actually, like, has a size and radius and everything, then yeah, you can actually observe that. And when it comes to heavy ion collisions, huh?
You guys actually measure?
Yeah, we can
change in the size.
Yeah.
Okay.
Yeah, we do this by colliding
any
heavy
specific
ions
references
together.
you can give me to look into that? Because I will follow through and check this out. What is it?
I mean, we have observed this in the
reference?
star. We have observed this in the star experiment at the relativistic heavy ion collider. When heavy ions collide with each other at very high velocities, they do not act like spheres colliding into each other. They act sort of like flat pancakes colliding into each other.
They're moving so fast.
Kind of like a stretched out
They are
toroid,
moving
if
so
you will.
fast that their densities actually change because they are flattened in the direction of travel. And we can see the
No way.
about because
Oh, this is ridiculous.
and vice versa.
So let's see here. I'd have to see how you're doing the analysis then. If it's not like the muon, that would change things. So yeah, I'd have to come back to that argument. May not apply then. No worries.
Yep.
So would you like to? What was the other thing we were about to move on to?
Well, I mean, as I said, just the fact that time dilation happens at all. Like, even if you were to argue that there's no reciprocity, that still doesn't prove the ether, because the ether doesn't predict there should be any.
What about time dilation in satellites and GPS?
Ether theory.
Yeah, that just
that you're using.
Guys, every time you bring
we observe it every day. Like, we can see there's definitely a relation between the mean lifetime of an unstable particle versus the velocity it's traveling at, and that trend follows exactly the curve that relativity predicts for any particle. And not just muons. Muons are just one of many unstable particles that we observe this with.
Accelerating through a medium could have the same extension. So I'd have to look at the new heavy ion thing. Huh? Well, vacuums still have electric permittivity and magnetic permeability. So like
Yeah, but it's
those
not a
are what
medium. That's
I
just the
say are.
permittive. It's literally called the permittivity of
Oh,
free space.
yeah. So like just because it's called that though, like nothing doesn't have physical impedance properties that are measurable. So like there has to be something physical there for there to be impedance. Otherwise, that's not a real concept. So like
I've
while you
also
can,
never heard of a single mechanism that would relate the interaction with, vacuum particles, with the lifetime of that particle.
What?
yeah, well, again, I'd have to
I don't
look
want
at
to.
what
And then, and
you're
then,
presenting
and then,
specifically
even
because
if
this
there
is new
was a
information.
relation, even if there was a relation between the two, you would expect that it would be wildly different than what relativity predicts. Because, like, what are the odds that they just happen to predict the exact same thing if it's a completely different mechanism? And it's also
Well,
related to the speed of light, too.
the mechanism proposed for, uh, Lorentz symmetry was originally proposed as like a compression mechanism going through ether to begin with to get the same velocity ratios of how it would be compressed in that medium. And I don't know if you're aware.
Oh my god, is this gonna happen every time? How do we get past this?
He derived Fresnel drag, a function being proportional to the square of the refractive index. It wouldn't surprise me if they knew these values because that was all derived in 1812, which is like
Well, I
crazy
can
because
tell
it
you with
predates a
confidence
lot
that
of
we
other people.
don't.
Yeah, go ahead.
I can tell you with confidence that we don't use those in simulations that actually model these high energy collisions.
Well, no,
And
but
our
what I'm saying
simulations work
though,
really darn well.
no, I got you. But I'm saying the gamma factor correction, like as a function of velocity through a compressible medium or the change in space time, mechanistically would have the same kind of effect. Like you're going through the medium with a velocity and you're going to have a function of change, in relation to
But
that.
no, wait.
So that,
We would
go ahead.
expect if it's related to the medium, then we would expect time
Mhm.
dilation to be different if it's in a near vacuum versus if it's in like air. But we don't see that either.
Every time?
Uh,
Unfortunate.
no, that's what I'm thinking about. Like I would have to calculate it out, but I assume it would be something that isn't
Yeah, you
measurable,
can't
really.
assume.
Hang on a second.
That's
You
How,
have
true.
to
No, you're
calculate it
100% right.
explicitly.
hang on a second. Hang on a
You
second.
are right. I
How
would
are
have to
you
come back on that.
how are you a flat earther and you're doing math? How does that work?
Wow.
Would you guys like to see a celestial theodolite?
I want
What the heck, bro? I already did follow him.
space is a perfect vacuum. And secondly, the expansion of space is not related to what's inside space. There's something
Yeah.
called a scale factor, which determines how distances in space are changing over time. But that's an unrelated topic. So yeah. But going back to the high energy collisions, muons are just one of many unstable particles that we observe this with.
Alright. I think I know what it is. I think I know what it is.
Depends on their energy, because they have
stay
a
active.
lifetime that depends, again, on how quickly they are traveling. The faster they're traveling,
Okay.
the longer they can stick around
Is it?
for.
Do you know how Compton scattering is calculated?
Roughly, yeah. That's. I mean, I reviewed it a long time ago, but
Do you happen
what
to
about
know
it?
off the top of the dome that, or if the calculations that they're using for their predictions are similar to that?
No. The Compton scattering is a very low energy reaction. We do have
I can't do this, guys.
a term for it. It's
Why is it doing that? You have ad block off, and yep. All right, let me
yeah.
try my stream. We'll swap out. Hang on. Is this most
डबल
recent
टैप
one?
रोड से और टीम ज्वाइन कर
All right, hang on.
It's just doing it, dude.
Yeah, but last time it was doing it for me, and then it worked on yours. So let's try my stream.
All right.
See if it works. Hang on. Pulling it up.
Oh, whoa! It popped back up when I stopped streaming. You think it's picking up Discord stream by chance? Sorry, guys. Just switch streams. I think it's picking up the Discord hook protocol, bro. It literally came back as soon as I stopped streaming. Yeah, dude. TikTok is picking that up, bro.
There's a Discord setting that stops it from doing that. You might be able to Google that. We could find it out.
Yeah, I'll look it up. Bro. Even if I just wanted to listen to the stream normally, it's still doing it.
Alright, I changed the setting. Let me retry streaming it. Hold up.
Yeah, we'll just hop back and forth.
Spectrum.
Oh,
That's a
gotcha.
very, very cold process.
I'll just keep yours muted and vice versa.
Are they still going at it? Like, have they
Yeah,
gotten
no,
to talk about anything
my
yet, or are they just
specific
trying
research
to
is
say
involved in
it's
understanding
useful
the spin structure of the proton. Essentially, we know that the proton is made out of quarks and gluons,
We're just talking about a
and
freaking
we
topic.
know that the total spin of the proton is somehow a combination of the individual spins of the quarks and gluons, but also like the actual orbital angular momentum from those quarks and gluons all orbiting around each other. And my research is looking at a specific channel that can see how much of the total spin is coming from that orbital component.
And the spin is determined by the dipole alignment, or how does that?
The proton's a composite particle, so the total spin of the proton is determined by the individual spins and also the individual momenta of each particle that it's made out of. And it's in each individual particle, it is related to the dipole moment of that particle.
Okay, so you're saying you're looking at you have these collisions and you have a dipole alignment that comes out of that. And
but we're not really looking at the dipole moment. That's just a related topic. I'm looking more into like the distribution of momentum inside of the proton. So like literally, it's an asymmetry term in terms of like when you collide something with a proton, how likely is something going to be thrown to the left versus thrown to the right due to the fact that things are spinning around inside of the proton. That's a very simplified version of what I'm working on.
Okay, yeah, so you're looking at like the mediated forces that would come out of that. Then, right?
My YouTube gets like 5.
How the momentum is exchanged with the probe.
Gotcha.
But it's working as I have my ad blocker on, so I think it works better.
For now, I've tried mine on.
Cool. Well, thank you, man. I look forward to learning more about that. One of the things I haven't dabbled in is the quantum chromo stuff. I've dabbled a little in QED. So this will be awesome to look into.
QED is baby stuff. That's baby.
Oh, that's the baby tier? Okay.
Yeah,
respect.
no, QCD. Look, QED is nice because all of the equations converge to nice finite values. But in QCD, you have an unfortunate process where the gluons do something called self-coupling. Essentially, the particle that's responsible for exchanging the force between particles itself feels its own force, which makes the math insanely difficult. And this is the realm of something you might have heard of called lattice QCD. It's a way of essentially trying to brute force a solution using supercomputers, and even those have a hard time trying to figure it out. And that's why there's a lot of experiments going on now under development to try to figure it out.
Are you talking about for the QED stuff?
QCD.
Or for the QCD. So the way that I read into it, there was a paper called it's like there's something wrong with QED by something Kanza, and he basically laid out the narrative of how, starting with Lamb shift, they had an expected energy value for what an electron should be going around the nucleus of a what do you call it? The nucleus of what was it? I want to say hydrogen. I think it was hydrogen. But anyway, when they took the spectroscopic measurements, the energy value was higher than they expected. And then so it started with a guy named Hans Bethe who came up with a little coefficient to explain it. And with that, it was like everyone was like, "Oh, okay, cool, no way. You just got to tell us how you derive that." And he was like, "Ooh, well, hold the phone. I don't actually know how." Like, he didn't say this, but he's just like he could never substantiate how he did it. And then this other guy named Schwinger came along, and he had a different coefficient, but still equally as valid. And it was even prettier because it was like, I forget what it is off the top of my head, but it was only like 2 variables or something. So it looked very clean, and everyone went with that. And then he was asked like, "Hey, how'd you derive that though, by the way, homie?" And he was like, "Oh, no worries. I'll do a presentation for you at the Solvoy meeting."
Okay, guys,
this is not relating.
No, you're good. I'll wrap it up. But long story short,
I know that QED was mostly pioneered by like Richard Feynman, and I think that's what he got the Nobel Prize for. And it has
we were about to get to
yielded some of the most accurate physics measurements that humans have ever produced. So
Alan,
the big one is the anomalous magnetic moment of the electron. That one is good to like something crazy like 13 decimal places or something, which is an absolutely insane quantity.
You said about a minute ago they were doing a lot of experiments with QED. Is that what you were saying, Quantum?
Is this going to be the first point where
I said a lot of things.
Variable?
They started with Lamb shift when they were getting into it.
Yeah, but experiments are cause and effect relationships. What would be the observed natural phenomenon?
We're not going over this now.
What is
your idea of an experiment is like a fifth grade version.
The observed natural phenomenon would be the spectroscopic lines based off of the. No, I can answer his question now. Like
that's not what we do in science.
Well,
no, he didn't.
I understand.
Pick them, which is why I've been saying I need to get rid of my mods. I didn't know if you wanted me to do anything.
Listen, I understand his position though, and I can help relay your position to him because I can describe the naturally occurring phenomenon, and that would be the spectroscopic lines, and the prediction
that kind of
would be.
It's missing the point
go ahead.
Of science. The whole point of science is to predict. You come up with an idea, you predict something new with that idea, and then you test the idea by comparing reality with that prediction. If the prediction is true, then that lends to more evidence for your model. If the prediction is not true, then you got to figure out where it went wrong. That's essentially the core of science. The whole natural phenomenon. That's like a handheld version that they teach
you have the natural
fifth graders.
It's super relevant and it's the backbone, but you have the natural phenomenon. You just didn't articulate it to him. That would be the spectroscopic readings.
He wouldn't listen anyways. I've told him I've tried fitting to his weirdly specific version of the scientific method, and he just never has it.
Yeah, I've never seen anyone from either side try to articulate like natural phenomenon, and because like we get a lot of pushback for interferometry readings, and they're like, "What's the IVDV?" And it's like the fringe patterns and wavelengths are all real, measurable, things that occur in nature, like radiation.
You also don't
natural.
need
you can measure the wavelengths.
Independent and dependent variables necessarily. Like there's a lot of observational science done out there.
Well, that would be just based off, that would be empirical observation, and that would just be kinematics. So like you really
Well,
need to
you can still
introduce
test
dynamic asymmetry
ideas.
to
I
make
mean,
definitive claims.
you can still test ideas
To
with
an extent, for
observations.
sure. To an extent, for sure. But to have a meaningful extrapolation, you do really need to introduce an IV-DV manipulation for sure.
Eh,
But
I wouldn't say so. Take for
I mean,
instance the
that's
LIGO
fine.
interferometers.
Mhm.
Those I think very much easily confirm that gravitational waves exist, especially when it comes to the detection of gravitational waves from colliding neutron stars, because those were also observed using light. Not just observed, but predicted. So what they found is that they observed a ripple of gravitational waves through these detectors, and they triangulated what location in the sky this ripple came from, and then they told a bunch of actual telescopes, hey, point your telescopes at this region of the sky and see if you see something. And then, like a few hours later, bam, a new point of light appears in the sky. So they were actually able to predict a new light appearing in the sky after their detection.
Yo,
What would be your example of an experiment without an IVDV?
It's not an
One
experience, it's an
second.
observation, but it's
Okay,
science.
so-
That's my point.
so-
It's
You
a
would have
prediction that
to-
comes
All
true.
right, guys, this has been going on for literally half an hour now. Damn near.
Oh, do you want us to not talk about, or
Well,
do
I
you want us
just
to leave? Or
no.
what?
There's other people here.
Oh, sorry.
Nah, it's fine. I just like other people want to talk.
I also will need to get going soon. I have an early day tomorrow.
No worries.
So sorry, Mech. I think I might have to drop out.
All right, that's fine.
All right, see you later.
Yeah, no worries, lad. It was a pleasure talking to you, man. We'll definitely follow up.
Later.
No offense, Mac,
Yeah,
but
my
my
bad.
questions were for Quantanaut. But no, that's cool. Thanks, Alan, for joining. Shane, I appreciate you
I'm
for letting
also a
us in, Mac.
scientist. You can ask me.
These are some of our questions. Yeah, I did have a question for you too, because last time we spoke, we usually have good conversations. It's actually the Globers that derail us. But you were telling me about, I believe, either your thesis statement or something you were working on for school, like pertaining to gravity. You told me it was like a whole bunch of math and numbers. I couldn't really explain it to my friends. Some of my friends are in here and down there. But if you felt like giving like a brief synopsis of it, that would be great.
Yeah, no, that wasn't me. I'm not working with gravity. That's not my field.
Wasn't it your life? Who could it have possibly been? And B. Liddy was there too, but I don't think it was B. Liddy.
Which live you talking about? Richard?
Thanks, Level. I wanted to block him, but I'm doing something right now.
Who you block?
I didn't block any. I said thank you to Level. I wanted to block Gene out of here, but I'm doing something and my hands aren't free.
I can block. Yeah,
I didn't know what you wanted me to do. I'm sorry. I literally didn't know what you wanted me to do. Because usually when I do anything,
Gene is like an automatic.
Yeah, Gene's an automatic block.
Okay, I'm sorry. I didn't know.
I'm soldering. I can't really do anything with my hands right now.
I apologize.
I'm playing Rocket League. I
I
can't do
really
anything
didn't
right
know
now. I could block him, but I
Hey,
can't.
yo, lads, I'm gonna bounce out of here. I appreciate you having me on.
Later.
Yeah.
See ya.
Because right now I'm doing research, and whenever I try to posit an observational study, they're like, oh yeah, this is observational. Like, what can you
Hello?
Yo.
Yo, what's up? I'm still live, by the way.
All right. Thanks for the heads up.
Yep. Gonna go ahead and wrap it up here. Had a decent night. I got some new stuff to look into.
I guarantee you it's going to be the same conclusion with QCD or whatever. And he even admitted it is they need to use supercomputers to basically siphon through the data.
Well, so I don't know what they use specifically for QCD, but he kind of had the narrative backwards about how in QED they converge to normalization, the normalizations lead to convergences, which isn't true. And then he's like, well, in QCD we actually use supercomputers because it goes to infinity, and it's like, oh, Well, it does the same thing in the other one too. So like, yeah, I can't wait to dig into that. That'll be awesome.
Hence why there's like a million Feynman diagrams.
Yeah, we couldn't really get into that.
I know.
But yeah, I would have liked to. It was building slowly. All right, let me wrap up here. So tomorrow night, lads, tune in. Shane and I will be hosting our own space. Where we will be presenting the old celestial theodolite. We didn't get a chance to pull it out tonight, but we'll be going over that for sure. And then Friday, of course, will be Flat Earth Fridays and/or Ether Cause community Twitter space, depending on whether or not Proud and Sacred are back from vacation. And then Sunday will be an extra special Glowbusters episode where Dr. Mike Heffron is going to go over the celestial theodolite himself and break down his journey into becoming a flat earther, where he used the theodolite and the stars to falsify the globes. Guys, they said it couldn't be done. My man whipped out a theodolite, pointed it at a mountain, and used it to falsify the globe. Find out how on Sunday.